Hello everyone and welcome back to Tech classes. Remember, in the first chapter, Introduction to AI, we have studied about three terms, AI, ML and DL. Any machine that mimics human behavior is an AI-enabled machine. Machine learning is a subset of AI where machines have the ability to learn and improve from data and experience. And deep learning is a subset of ML that uses a special type of algorithm called artificial neural network. And these artificial neural networks behave exactly like human brain. And in today's video, we will learn about how an artificial neural network works. So, without any further ado, let's start the video. If you find this video helpful, please remember to like, comment, share and subscribe. Your support will help us to keep this channel running. The concept of artificial neural network was first proposed in the year 1944 by Warren McCloud and Walter Pitts. This concept was very widely used in early 80s and early 90s, but due to the hardware limitations at that time, its popularity diminished. Neural networks are loosely modeled after how neurons in the human brain behaves. It is a fast and efficient way to solve problems for which the dataset is very large, such as images, videos, sounds, or speech. An artificial neural network is basically a group of algorithms, and these algorithms functions just like the human brain cell called the neuron. Means in artificial neural network, programs are designed to solve any problem by trying to mimic the structure and function of our nervous system. Let's first try to understand how a brain cell works. So this is the structure of a human brain cell called the neuron. Like any other biological cell, it has a nucleus in it. Dendrites are the part of this cell from where this cell receives input. And this area is called the axon, where the cell does some processing. And finally, the cell produces output from the axon terminals. Do you know that there are almost 86 billion neurons in a normal human brain? And all these neurons are connected to each other. Every neuron receives an input, then it does some processing in it, and finally produces some output. The output of first neuron becomes the input for the next neuron. There again some processing is done and then the output is produced. And this process continues till the final output is not produced. And the artificial neural network works in the same manner. An ANN is a collection of nodes, and these nodes work in the same way as the human brain cell works. Means each node receives some input, does some calculations in it, and then produces some output and then passes it to the next node. All the neurons are divided into three layers: an input layer, a number of hidden layers, and an output layer. Each layer is further divided into several blocks called nodes. Each node has its own task to accomplish, which is then passed to the next layer. Here, the connections between the nodes are called the edges. The first layer of the neural network is known as the input layer. The job of input layer is to acquire data and feed it to the neural network. No processing occurs in input layer. Next to it are the hidden layers. Hidden layers are the layers in which the whole processing occurs. There can be thousands of hidden layers in a neural network. Each node on these hidden layers has its own machine learning algorithms which it executes on the data received from the input layer. The processed output is then fed to the subsequent hidden layer of the network. There can be multiple hidden layers in a neural network system, and their number depends upon the complexity of the function for which the network has been configured. Also, the number of nodes in each layer can also vary accordingly. The last layer passes the final processed data to the output layer, which then gives it to the user as final output. Similar to the input layer, the output layer too does not process the data which it acquires. It just produces the output. Now, let's quickly try to understand how these nodes calculate values. Suppose this is a node. Now, the nodes at the previous layer passes values to this node with the help of connectors. There is a value associated with each connector, and this value is called the weight of the connector. Means the connector passes the previous layer values along with their weights. Now every node has a value associated with it, and this is called the bias of the node. We know that every node is actually a machine learning algorithm. Now this algorithm uses a function called the activation function. The activation function uses previous results along with the values of weights and bias and calculates a new value. This value is now passed to the next layer node, and the same process is repeated at each node. Now let's try to understand how an ANN works with the help of an example. Suppose we have created a neural network that can identify the images of a car, a dog, and a flower. Now, if we ask the neural network to identify the image of a dog, then the neural network will identify the image on the basis of its features, right? In a dog's image, the data features can be his eyes, ears, or nose. The key advantage of a neural network is that it is able to extract data features automatically without needing the input of the programmer. A computer model can understand the numerical values, so the input layer will receive the numerical values of these data features. So we have seen how the input layer receives the input. Now the nodes of this input layer passes the results to the nodes of next layer with the help of connectors, also called the edges. Now by using the results of previous layer nodes, weights of the edges and biases, these nodes apply an activation function and calculates a new value. Now these values are passed to the next layer with the help of connectors. Now the nodes at this layer use some activation function and calculates a new value, and this process continues till the last hidden layer. Now the last hidden layer passes the results to the output layer. At the output layer, the node with the highest value is considered as the final output. So in this way, here the image is identified as a dog's image. This process of calculating the results by each layer and passing it to the next layer is called the forward propagation. But suppose if the model produces a wrong output, now the reason of wrong output can be the calculations of wrong values of biases and weights. So the ANN moves back to readjust the values to get the correct results, and this process of moving back to relearn is called the backward propagation. ANN repeats the same process until it gets the correct output. In this way, the artificial neural network uses hit and trial method for learning. And this type of learning is called the reinforcement learning. So if we summarize, the nodes of ANN are divided into three layers: input layer, hidden layer, and output layer. Input layer receives the input. There can be a number of hidden layers. The nodes at the hidden layers uses a machine learning algorithm and some hidden rules to produce an output. This output is then passed to the next layer, There the same process is repeated again and again till the final output is not produced. Well, the main objective behind ANN is to develop a system to perform various computational tasks faster than the traditional systems. Let's try to understand this with the help of a graph. Let's keep the training data size on the x-axis and the model's performance on the y-axis. Traditional machine learning algorithms stop learning after a particular time, and so their performance stagnates. A small artificial neural network learns better than a traditional machine learning algorithm, so it performs better. A medium ANN learns even more, so it performs even better. But a large neural network always keeps learning, and so its performance always keeps on improving. Some areas where ANN can be used are real-time translation, the radar or the surveillance systems, face recognition, image compression or image feature extraction, medical science or healthcare, speech recognition, text recognition, or ANN is used for recognition of handwriting or conversion of the handwritten content to printed text content. So this was all about artificial neural networks. In our next video, we will cover another machine learning algorithm, the decision tree algorithm. So that's all for today. Thank you so much for watching. See you in our next video. Till then, take care and bye bye.